Hi guys, welcome to lesson 13 of our geography series. In this class, we are going to learn about planetary winds and seasonal winds. Okay, planetary winds are those winds which blow or which show their action on entire region of the earth. Okay, they are not confined to particular place. They show their influence on entire region of the earth. And seasonal winds are subunit of planetary winds which are originated during particular seasons of winter and summer. Okay, next, these planetary winds are induced due to development of different pressures at different latitudes. Okay, due to development of different pressures, that is high pressure and low pressure at different latitudes, that is at equator or at polar region, the gradient is developed. High pressure to low pressure gradient is developed. Due to that gradient development, winds blow from high pressure to low pressure region, and they induce planetary winds. Okay, so in order to understand planetary winds, first we have to look at development of different pressure cells or pressure belts at different regions of the earth. Okay, yeah, let's look into it. It is equator, it is polar region, subtropical region, subpolar region. All right, yeah, this condition is during equinox. Okay, what happens during equinox? During equinox, sun rays fall vertically on equator. Okay, at this region, that is equator in the sense not only 0 degree, from 5 degree north to 5 degree south. Okay, at this region, sun rays fall vertically. So this region is heated up very rapidly, very intensely. Okay, due to that intense heat, a low pressure is developed at the equatorial region. Okay, and at polar region, comparatively, it will be much colder due to less temperatures. The air developed will be cold, and the colder air descends down. So like this. But at equator, what happens? The air rises up due to that. As it got intensely heated, the hot air rises up to stabilize. So at equatorial region, air rises upwards. Okay, and it hits tropopause. After hitting tropopause, one branch of the air moves towards southern hemisphere and another branch move towards subtropical region. All right, yeah. After traveling for certain distance, what happens at this higher level of tropopause? Temperature will be very less, so the air gets cooled. The cold air will descend down, again hit the surface and travel towards equatorial region. This circulation develops a cell called as Hadley cell. Yeah. Next, if you look at here at polar region, air descends down. After hitting the surface, this cold air travels towards subpolar region. After reaching subpolar region, the air rises up. Why? Comparatively, subpolar region will be hotter compared to polar region. Subpolar regions will be hotter. So this hot air rises upwards. As it rises upwards, it hits the tropopause. After hitting tropopause, one branch move towards polar region, and the branch that move towards polar region descends down, because at polar region temperature will be much less and the air gets cooled and descends down. This results in the development of polar cell. Okay, next, we said that one branch move towards polar region and another branch move towards subtropical region. Moving towards subtropical region, this branch gets cooled down at tropopause and descends. hit the surface at subtropical region and diverges. After coming to subpolar region, it again rises up. Why it rises up at this point? Because due to Coriolis force, the the air that is coming from subtropical, the branch from subpolar is traveling towards subtropical region. At tropopause, the air will be cool, so it descends down at subtropical region, and at subtropical region the air will be hotter. It diverges, and this hot air travel towards subpolar region and rises up. Why it rises up? Due to Coriolis force, the air deflects rightward. From this, he deflects rightward and rises up. Okay, and this develops ferrule cell between subpolar and subtropical. Okay, at equatorial region we have low pressure due to high temperatures. At polar region we have high pressure due to low temperatures. But at subtropical region, here we can see divergence of the air. Whenever the air diverges, here we can observe high pressures. Why we have explained in the first class of climatology that uh, hot air expands and rises up, so that low pressure develops in that area. Whenever low pressure is developed, air from high pressure converges at low pressure. So whenever there is convergence, there will be a low pressure, and cold air descends down and it travels towards descends down. So a high pressure is developed, and that high pressure travel towards the low pressure areas. So there is divergence at high pressure areas. So at subtropical region we can see divergence. Whenever there is divergence, there is high pressure. At subpolar region, there is convergence of it. Look here. So it is low pressure. And so due to the movement of these winds, we have different sorts of high pressures and low pressures on the entire earth. Okay, and due to this circulation of air in the atmosphere, three types of cells are developed. These are Hadley cell, ferrule cell, and polar cell. Polar cell present between polar region and subpolar region. Ferrule cell present between subpolar region and subtropical. And Hadley cell present between subtropical region and equatorial region. Okay. So the activities weather activities happen in these cells due to atmospheric circulation of wind. Why this wind is circulating? Due to development of temperatures and pressures. See, the equatorial region and polar region, high pressure and low pressure are developed due to temperature. So it is thermally induced. In subtropical and subpolar region, high pressure and low pressure developed due to convergence and divergence. So it is dynamically induced. So due to temperatures and pressures, different types of pressures are developed at different parts of the earth. These are called as pressure belts. Due to these pressure belts, winds are circulating in certain way and developed three types of cells called as polar cell, ferrule cell, and Hadley cell. Similarly, these cells will be seen in southern hemisphere also. Okay. So at the end, what is atmospheric circulation? The circulation of these winds. So these winds circulate and carry with them temperature, heat, water vapor, uh, dust particles, uh, air masses, and results in certain climatic activities. Yes, this is about development of different types of pressure and movement of winds. Okay, and this theory is called as tricellular circulation. Due to this tricellular circulation, we can see different weather activities on Earth as the winds are blowing in from equator to polar region. Sorry, as pressures are developed from equator to polar region. Due to this development of pressures, there is movement of winds. Okay, now we look into it. They are planetary winds. Due to development of that of those pressures, there is um, uh, there is initiation of planetary winds. Okay, how these winds blow, we look into it. 5 degree north to 5 degrees south. Okay, and 25 to 35 degrees subtropical. 55 degrees to 65 degrees, it is subpolar, and it is polar, 90 degrees. Similarly, in southern hemisphere also, 25 to 35 subtropical, 55 to 65 subpolar, and at 90 degrees we have polar region. Okay, this is low pressure area, subtropical high pressure area, and again 90-degree polar is high pressure area. Similarly here, it is high pressure area, low pressure, high pressure. Why high pressure, low pressure? We have just learned due to development of these pressure belts. And at equator we have low pressure. Okay, due to vertical falling of sunrays on the equatorial region. Okay, yes, this region is called as ITCZ. What is ITCZ? I will explain later. ITCZ is a region, for now you remember that ITCZ is a region where sunrays fall vertically and there will be an intense low pressure. Okay, due to this intense low pressure, whenever sun rays are falling vertically on equator, ITCZ develops where there will be intense low pressure, and winds in equatorial region will blow from west to east. Okay, west to east. Why? There is no Coriolis force at the equator, so there is no deflection in the equator, and winds blow from west to east, and these winds are called as doldrums or equatorial westerlies. Yes. Next, from subtropical high pressure, winds blow towards equatorial low pressure. So winds coming like this from subtropical high, and they deflect towards right, and they blow like this. And these winds are called as northeast trade winds. Why northeast? The naming of winds is in such a way that they are named according to their origin. See here, the origin is at northeast direction and they are blowing from northeast towards west. So they are called as northeast trade winds. And from subtropical high, winds blow towards subpolar low like this. And they deflect right. Okay, and they travel like this, and they are called as westerlies because the point of origin is west. They blow from west to east. They are called as westerlies, subpolar westerlies. Okay, and from high pressure polar region to low pressure subpolar region, winds blow, and while blowing they deflect towards right. Okay, and they blow like this. They are called as easterlies, polar easterlies. Why easterlies at polar region? Because as Coriolis force is very much higher at the polar region. As we move from equator to poles, Coriolis force increases. There will be more deflection. So the deflection that's happening at polar region is very much higher. So that the winds will blow from east to west in a horizontal way. Not like our northeast trade winds. The deflection is low at subtropical regions. So they blow as northeast trade winds, but the deflection is very much higher at polar regions, so they travel as easterlies, that is from east to west. Okay, similar scenario in southern hemisphere also. From subtropical high, winds blow towards equator, that they blow towards equator, and in southern hemisphere they deflect leftwards, and they are called as southeast trade winds. And from subtropical high, the winds also travel towards subpolar low like this. And here they deflect towards left and they blow like this, called as westerlies. And from polar high pressure, the winds travel towards subpolar low pressure and they deflect again leftwards. And as they are traveling from east to west, so they are polar easterlies. This scenario is seen during equinox, where sunrays are falling vertically on the equator. Okay. I hope that you understand this, how these winds are blowing, why these winds are blowing like this. So please do watch previous classes of climatology and Coriolis force especially. Okay. Due to Coriolis force, the direction of wind is deflecting in different directions. So so these high pressure and low pressure belts are resulting in generation of planetary winds. Okay. Yeah. And seasonal winds. Before learning seasonal winds, we have to learn about ITCZ. Okay, ITCZ means intertropical convergence zone. Okay, whenever sunrays fall vertically on particular region, ITCZ is developed on that region. ITCZ is developed on that region means whenever sunrays fall vertically on certain region, intense low pressure is formed at that region due to high temperatures. Okay, and intense convergence happens. Okay, as it is low pressure, winds from high pressure area travel towards this low pressure and rapid convergence happen in this zone. So it is called as intertropical convergence zone. Okay, during summer what happens, the sunrays slowly start shifting towards northward and they are at 90 degrees at tropic of cancer. So this ITCZ also moves from equator to Tropic of Cancer. Due to this movement of ITCZ from equator to Tropic of Cancer, there develops a new type of winds called as seasonal winds. So we look into it. Equator, it is ITCZ, that is 23 and half degrees north. It is during summer. Okay, summer, 23 and half degrees north. Similarly, subtropical high pressures, subpolar low pressure, and polar high pressure, low pressure, high pressure. Similarly, in southern hemisphere also, subtropical high pressure, subpolar low pressure, polar low pressure. Sorry, high pressure. Okay, yeah. So what happens? Uh, the ITCZ is shifted towards north. Okay, that is on Tropic of Cancer. So there will be rapid convergence happening at low Tropic of Cancer, and there will be an intense low pressure. Low pressure. This low pressure is very much intense. So whenever southeast trade winds travel like this, they surpass the equator and enter into northern hemisphere. Okay, southeast trade winds surpass equator and they enter into northern hemisphere. When these southeast trade winds enter into northern hemisphere, what happens? They deflect rightwards and southwest trade winds are generated. Southwest trade winds. Okay, why these winds travel for such longer distance, almost from tropical regions of southern hemisphere to tropical regions of northern hemisphere? These winds travel, why they travel aggressively to such large distance means the low pressure developed at the ITCZ is very much high. Okay, so that the gradient is very steep. The difference is very much higher, so that more is the difference, more is the velocity of the wind. More is the velocity, more is the deflection. So once they surpass the equator and enter northern hemisphere, they deflect rightwards in northern hemisphere and results in the formation of southwest trade winds. Okay. So in India, we experience a monsoon called as southwest monsoon, and these winds are responsible for that. Okay, and I will explain in detail when we discuss about Indian climate specifically. Okay, and remaining things are common. From subtropical high to high, winds travel towards low pressure regions of ITCZ and equator. Whenever they travel, sorry, where were we? We are at seasonal winds, right? Please give me a minute. Okay. Whenever they travel to northern hemisphere, they emerge as southwest trade winds. Southwest, southeast. From subtropical high towards low pressure, winds blow as northeast trade winds. Northeast trade winds. And from subtropical high to subpolar low, winds blow as westerlies. Remaining winds are common. There is only initiation of or genesis of new winds in Tropic of Cancer region, that is ITCZ region of northern hemisphere, called as southwest trade winds. Please do keep that in mind. And from polar high pressure towards subpolar low pressure, we can see easterlies that traveling like this. Okay, yeah. This is in summer. Again in winter. In winter, what happens? Southern hemisphere comes under the influence of the sun, so that uh, sun's rays fall vertically on Tropic of Capricorn. So ITCZ is developed on Tropic of Capricorn. So it shifts from northern hemisphere towards southern hemisphere, and it looks somewhat like this. Equator, 23.5 degrees south, ITCZ, low pressure, and remaining things are common. 30 degrees high pressure, 60 degrees low pressure, 90 degrees high pressure. Here also subtropical high pressure, subpolar low pressure, and polar high pressures. Okay, see, so from during this, what happens? Whenever winds blow from northeast trade winds blow from high pressure to low pressure regions, they surpass the equator due to development of gradient, rapid gradient at ITCZ. They that these northeast trade winds surpass equator, enter southern hemisphere, and they start deflecting towards left. Once they start deflecting towards left, what happens? The winds will blow like this. These are called as northwest trade winds. Okay, during winter, northwest trade winds are induced. So remaining winds are common. That is between subtropical high and subtropical high and equatorial low. We can see southeast trade winds. Between subtropical high and the subpolar, we can see westerlies. Between polar high and subpolar low, we can see easterlies. All right. Two new types of winds are generated during winter and summer. They are called as southwest trade winds during summer and northwest trade winds during winter. Okay, why they are formed, why they are induced, we have discussed every logical reason behind it. Okay, and my sincere request is to please do visit this class once again. Please do learn that how different types of cells are formed, why they are formed, why different types of pressures are formed, whether it is thermally induced or dynamically induced. Please do learn and please be thorough with it so that it helps in studying Indian climate specifically and world climate in general. Okay, because of these winds and because of the development of this high pressure and low pressure, we are going to learn about why deserts are present on certain sides of the continent, why grasslands are present, why deciduous forests are present in certain regions only, why soils are leached in certain regions only. So please be thorough with how winds are blowing, why they are blowing, how pressures are developed, pressure belts are developed, why they are developed, how temperature is distributed on entire Earth. Okay, please do learn about it. How seasonal variations occur. Please be thorough with with these basic concepts so that it will be easier for us to study about world climate in a much easier way, and it is very much helpful for us to study physical geography and not yeah, physical geography of India and monsoons in India. Okay, yes. Okay, we have said that planetary winds blow on entire region of the earth. While they are blowing, they influence weather patterns in certain regions. Okay, so whenever they are blowing, they blow on the oceans and they develop a certain phenomena called as ocean currents. Whenever planetary winds are blowing over the oceans, they make the oceanic water to move slowly in a certain way. So this moving slowly in certain way or certain direction is called as current. Okay, so as it is happening in ocean, it is called as ocean current. Okay, in next class we will look into what is ocean current. These planetary winds and ocean currents together influence the climate of any region. Okay, how we will look into it in next class. So with this class, you please be thorough with the winds, how they are blowing and why they are blowing. And in next class, we will learn about ocean currents, why they are induced, why they are warm and why they are cold, or why they are moving in certain directions, and how these winds and currents together influence the weather of certain regions. Okay? Yeah, yeah. That's all for today. If you have any queries or any doubts, please do let me know in the comments. Uh, Even if you want to learn any specific topics, please do let me know in the comments, and yeah, we will work on it. Thank you. And in next class, we will learn about ocean currents. Make sure you have a political map with you in next class so that it will be easier for you to draw along with me and easier for you to study also. Okay? Yeah. Thank you.